Hello and welcome back. So we're ready to start implementing this item interping state. One of the first things we need is the camera location that we're going to interpolate to for our item. So we're going to create a function on the character class that will return an f vector that gives us this interp destination. So our character has a camera. We'll represent our camera as this blue shape here. And the camera has its own location. We'll represent that by this red dot here. Now, we want our items to interpolate to a certain location that's relative to the camera, but not exactly here on the face of the camera. We want it somewhere up here. So it's going to be slightly outward and upward by a little bit. So we need a function that will return this desired location. Now we can easily get the camera's location as well as the camera's forward vector. We can use that information to find a location that's moved outward a little bit away from the camera. We can also very easily get the camera's up vector, and we can use that vector in order to move this location upward towards the desired location. The way we do that is like this. So we're getting our camera's location and we're moving it outward by some amount, call it A, and then we're moving it upward by an amount, call that B. So our desired location can be calculated by getting our camera's location and adding its forward vector, which is a unit vector, it has a length of 1, multiplied by A, this distance that we want to move outward. And then we can also add the up vector, which is also a unit vector pointing upward, and multiply that vector by B, which is the distance we want to move up. So these are forward times A and up times B. And by taking our camera location and adding these two vectors, then we end up with a location vector at the desired location. So this is the formula we're going to use for our function on the character class that will return our desired location. So let's make that function. So here we are in our shooterCharacter.h file, and we're ready to add a function that will get our camera interp location. I'm here in the public section because we're going to need to call this function from the item class, since we're going to use it in the item class to update the item's location. So let's go ahead and create the function here in the public section. It's going to return an f vector, and I'm going to call this getCameraInterp location. So let's go ahead and create the definition for this function in shooterCharacter.cpp. So here is our function. We've got the body here, and we're ready to fill this out. Now first we're going to need the camera's world location. So I'm going to make a const f vector and call this camera world location. And we're going to initialize this. First we're going to get our follow camera, and from the follow camera we're going to call get component location. This is how we can get a component world location from one of our components. So that's the world location, and we're also going to want the camera's forward vector. So let's make another f vector. It's going to be const, and this will be called camera forward. And we can initialize this by taking our follow camera and calling get forward vector. So we have our world location and our camera forward vector. So what are we going to return? Remember, our desired location is equal to the camera world location plus the forward vector times some value A, which is the distance outward from the camera. And then we're going to add the up vector times some value B, which is another distance that we want to travel upward. Let's go ahead and create a couple variables for A and B in shooterCharacter.h. Now these can be private variables, so let's go up to the private section here, and we're going to create a couple of floats. So the first float we'll call camera interp distance, and this will be a U property. And let's make this edit anywhere, so we can change this in blueprints, but we'll make it blueprint read only. Now we can give this the category of items, and we'll go ahead and give it the meta allow private access specifier as well. And we can comment and say distance outward from the camera for the interp destination. Now we'll create another float and we'll call this camera interp elevation. And I'm going to give it the same exact U property. And for the comment, we'll say distance upward from the camera for the interp destination. So now we have these two floats, and they can be edited in blueprints, but we're also going to give them default values in shooter characters constructor. So let's go up to the constructor, and we'll say that camera interp distance, we'll give that, say, a value of 250.f. And for camera interp elevation, we'll give this a value of 65.f. Now we can tweak these, but these are the values we'll start off with. And we'll say camera interp location variables. So back down here, what are we going to return for get camera interp location? So we're going to return, it's going to be camera world location, and we're going to add to this camera forward times our camera interp distance. Now we're also going to move our camera interp location upward, and we're going to do this by getting a vector that's pointing upward. So we're going to say f vector 0 in the x, 0 in the y. And finally, the length of this vector in the up direction will be camera interp elevation. We can do this because we know the camera will never be tilted. In other words, its roll will always be zeroed out. It'll always be level with the ground. So we don't even need to get the camera up vector. We just know that's always going to be in the upward direction of the world. So we're just creating a vector pointed upward with a length of camera interp elevation. So this is the function that will return our camera's interp location. So if we look back at our slide here, we're getting our desired location, which is the camera location moved forward and upward by these two vectors. So this will conclude this video. We now have a function on the character class that we can call to get the camera's interp location at any given frame. And it's a public function, so we can call this from the item class when we want to. Okay, we'll continue with our implementation of the item interping state in the next video.